Welcome back, class. Today we're going to look at a rational function and expression. So, rational function, what is that exactly? Rational function or expression is given that you have two polynomials and where you have one polynomial over the other. What you don't want to happen is that you do not want the bottom polynomial to become zero because anything over zero is undefined. All right? So, given that we have f of x and g of x are two given polynomial, if f of x over g of x becomes the rational function we're looking at, we do not want g of x to equal 0. Okay, now let's look at an example. The expression 5x squared minus 12x plus 4 over the expression x minus 2 is a rational expression. Ladies and gentlemen, what I want you to recall is the fact that a rational expression with variable in the denominator is not a polynomial. The numerator is a polynomial in its own right. The denominator is a polynomial in its own right. But together, since it is a fraction where you have a variable on the bottom, the expression together is not a polynomial. It is a rational function / expression. Okay? Now, ladies and gentlemen, adding rational expressions. Now, what you do, you follow the same step that you would use if you had to add two fractions. Nothing changed. It's just that everything we're doing now is in the field of polynomials. That is all. So we're still going to think in the same manner of adding two fractions. So as a result, we must find the common denominator, which means make the denominators the same. Once we do that, ladies and gentlemen, we would add like terms of the numerators. Okay, we would add the like terms. Then please always, ladies and gentlemen, simplify. You need not to be instructed to simplify the answer. Your answers are to be simplified at all times. So let us look at an example. When we look at the example 3x minus 2 over x plus 7x plus 4 over x, notice that the denominators are already the same. So all I have to do at this point is adding the numerators. And when adding the numerators, we simply combine like terms. So we get the following: 10x plus 2. That is it. Nothing more to it, ladies and gentlemen. Let us look at another. If we need to find the sum of the expression 3 over x plus 7 plus 4 over x minus 8. Again, are the denominators the same? No, they're not. Now we need a common denominator. The easiest way to proceed with common denominators, in this case, ladies and gentlemen, I strongly suggest you multiply the two denominators. So in this case, I would end up with this. And remember, I write it twice because I have two expressions on top. So whatever I did to the first expression, if you look at the denominator in the first expression, what I did, there was a x plus 7. I just multiply by x minus 8, the expression x minus 8. So whatever the top of the first expression is, which means whatever the numerator is on the first expression, I am going to multiply it by x minus 8. And the same thing for the second expression. I multiply the denominator by x plus 7. Whatever it is on the numerator, I'm going to multiply it by x plus 7 in this manner. At this point, ladies and gentlemen, the denominators are the same. So all I have to do is follow distributive property and combine like terms in the numerators. So we have the following. So I keep this the same. So, and I have 3x minus 24 for x plus 28. Combine like terms, and we end up with, ladies and gentlemen, 7x plus 4. And that's all there is to it. Nothing more. Okay, let us look at subtracting in this manner. Subtraction of rational expression can be a bit nifty because where you see the subtraction, that is a -1 going to multiply everything in the numerator of the second expression. So this, in other words, we could have written it as 6 over the expression x minus 1 plus -5x over 4. That would be the same thing. However, I want you to think that negative sign is a -1 that's multiplying, that you're going to distribute in the numerator of the second expression. So let us look at what we have. Since the denominators are not the same, we're going to have to make the denominators the same in such manner just as we did in the first one. The 4 was missing. I multiplied by the 4. In the second one, I multiplied by the x minus 1. As a result, ladies and gentlemen, I do the same thing to the numerators of the rational expression, which I have done to the denominators. So look at this, and I have 6 times 4 because that's what I did to the denominator there. So I do the same thing here, 5x times the expression x minus 1. Ladies and gentlemen, pay careful attention to the second expression as I distribute -5x to the expression x minus 1. Remember, I do not distribute 5x, I distribute -5x. Now that the denominators are the same, I simply do that, and I get 6 times 4 is 24, and -5x times x is -5x squared plus 5x, because it's -5x times -1. That's why it becomes plus 5x. So, ladies and gentlemen, I can distribute the denominator at this point and add like terms if there's any. In this case, there isn't any like terms. What I do, I just arrange it in a standard form for the numerator. As a result, -5x squared plus 5x plus 24 over the expression for x minus 4. And that is it, ladies and gentlemen. That is it. Now, let us look at another. In this case, the denominators are already the same. I do not have to do anything but simply combine the like terms of the numerators. Remember, the negative sign in front of the second expression is a -1 that is being distributed in the numerator of the second expression, ladies and gentlemen. Notice that. Now, since the denominators are already the same, so I can write it once and do the following. It is m minus 3n. Remember, the -1 times m is -m. -1 times 3m is -3n. Excuse me, -1 times 3n is -3n. Now, I combine like terms. When I combine like terms, I get -6n over 6m cubed n. Simplify. Always simplify, and we obtain -1 over m cubed. Okay, that's what we obtain, and at this point, this is your answer. That's it. Okay, let's look at another one. Again, ladies and gentlemen, the denominators are exactly the same. So all we have to do is distribute the -1 to the numerator of the second expression, and we have the following. Okay. All right. Combine like terms. And that's it. This is your answer right here. Nothing more to it. I hope you find this very understanding and that you are capable of completing your assignments.